en jullie ook een blik tonen van wat er komende maanden op de planning staat. Zoals gezegd, maandelijks gaan we proberen iets te plannen. Par exemple, pour les mois suivants, en décembre, janvier et février, on a déjà planifié quelque chose. Toujours dans le contexte du béton. En décembre, les gratte-ciel. En janvier, les armatures externes. Et en février, le massif passif. Mais pour aujourd'hui, on va commencer avec un de nos collègues en Suède, si je dis ça bien, concernant le béton autocompactant et les pressions sur les coffrages. Je vais passer le mot à Monsieur Richard McCarthy in Sweden. Christophe, kunt jij? Richard?
Yes.
Can you hear me?
Yes, I can hear you. Hello.
Okay, so it's up to you now. You have the word and the presentation.
Okay. Hello, everybody. I'm sending from a very cold Sweden. It's about 10 minus and about 10 centimeters of snow outside, so I hope you have a better weather in Belgium. So, Nikki, I suppose that you cannot interrupt me if something is wrong.
I could interrupt you, but I will avoid that.
Okay. Okay, so I'll start. Okay. This is my presentation. Comparison of 3 methods to capture the formwork pressure when using SCC, a field study. This is part of my research project, and I had this lecture on the SCC conference in Montreal about 1 or 2 months ago. As you have heard, my name is Richard McCarthy, and this is my presentation. I will talk about aim and description of the project, instrumentation, results of the measurements, comparison with simplified models in some way, evaluation of the project, and concluding remarks and future. One of the factors explained in the slow progression of the SCC technique is the issue of formwork pressure. It's either too conservative, or you might say expensive formwork, or reduced casting rates, reduced productivity. Controlling the casting rate while monitoring the formwork pressure at site is one solution to the problem. The aim of this paper is to investigate and compare different methods of measuring the formwork pressure. And the long-term aim is to develop simple, robust, and reliable measuring methods in order to monitor and control the formwork pressure.
Richard, if I can interrupt you, somebody says that they can't see your presentation. Did you select in the left top your presentation?
Left top. Do I have to do share again? No.
You could try that.
Because there is a window which says Richard McCarthy. I can see it, but you can't see it, obviously.
Yes. We can see it, but one of the attendees can't.
Okay, so what do you suggest? Shall I try share again?
I'll check with one of the...
Shall I try? Do you want me to share again?
I'm waiting for a reply for one of the attendees.
Okay.
Yes, you can try to read. You can retry to share your presentation. Apparently they can't see it.
Okay.
They can only see my presentation.
Okay.
One of the other attendees can see yours, so.
All right. Is it okay now?
I can see it.
Mm-hmm.
Okay, you can go ahead.
Okay.
Sorry for the interruption.
Never mind. I'll take it from the beginning.
Yeah, maybe fast.
Yeah, okay. This is, hello again, the comparison of 3 methods to capture the formwork pressure when using SCC. It's a field study. In the photo you can see, I will get back to that, but it's a prison up in the northern parts of Sweden. It's a very long prison wall where I measured formwork pressure. I will talk about aim and description of the project, instrumentation, results, comparison with simplified models, evaluation of the project, and concluding remarks and future. One of the factors explained in the slow progression of the SCC technique, I think worldwide, is the issue of formwork pressure. It's either too conservative, or you might say expensive formwork, or reduced costing rates. That means reduced productivity. Controlling the costing rate while monitoring the formwork pressure at site is one solution to the problem. The aim of this paper is to investigate and compare different methods of measuring the formwork pressure, and the long-term aim is to develop simple, robust, and reliable measuring methods in order to monitor and control the formwork pressure. Two prison walls, 1,000-meter long outer wall and one 400-meter long inner wall inside a new super prison for the most dangerous criminals in Sweden, as you saw on the photo. Measurements were carried out on the inner wall during 12 castings. The wall is 6 meters high and 27 centimeters thick. The formwork consisted of film-faced 15-millimeter plywood panel on steel frames. Castings were made in 12-meter sections, and it was finished in May 2009. As I mentioned before, it's located in the northern part of Sweden, about 40 kilometers north, 450 kilometers north of Stockholm. You see the red and yellow star. This is a view from the outside, as you also saw in the beginning. So what you can see is the outer wall. It's 1 kilometer long, 1,000 meter long. You can't see the inner wall, but it's in there. I will talk about the instrumentation. There were 3 identical steel frame elements used alternatively, and they were placed near the middle of the 12-meter section. They were mounted together in, as you can understand, 2.4 meter wide and 3.3 meter high. They were mounted in the middle of the bigger section. And they consisted of 2 vertical KKR profiles and horizontal VKR profiles. The formwork, the frame elements were equipped with pressure sensors, strain gauges on the steel frame, and load cells on the tie bars. And loggers and computer, I had them stored inside a movable steel container, which was, of course, moved between the castings. I think I will go ahead to the picture of the instrumented element. Here it is, inside the white ellipse. This is the photo of the instrumented element, 2.4 meter wide, and of course it's mounted together in the bigger section. So everything was lifted with a crane. So I will get back. This is in the beginning where we mounted all the gauges. It's a picture of the movable steel container. And you can see the table there with the computer and so on. So it was nice to have that steel cylinder container. It was very cold, as I said, it's up north in Sweden. And it could be 20 minus or maybe 10 minus. And everything was inside there, radiator and electricity and light, of course. So I was standing there watching the computer with the pressure values. This is the photo again with the instrumented form element. This slide shows one of the pressure sensors. It's Honeywell ADH. It's up to 689 kilopascals. It's mounting, as you can see in the photo, it's mounting in special made threaded steel plugs and sockets. It was flush mounted facing inwards. So the membrane was in direct contact with the concrete. I think this one is used in North America and Canada as well. This is a slide of the strain gauge. You can see under the foil that something is mounted there. It's glued. And it's a very small linear metal strain gauge. It's HBM. And you can see it's glued on the horizontal profiles and covered with paste and aluminum foil for protection. So it's measuring the strain on the back side of the formwork. And this is one load cell on the tie bars. It was manufactured by staff at the Royal Institute of Technology in Stockholm. It consisted of a hollow steel cylinder inside an outer steel pipe. It had 8 strain gauges on the inner cylinder, and the maximum load was 100 kilonewton. So where did we mount these gauges? This is the picture of the